Hello, it's new module time, or new old module time. This is the Tágh, which is all analog sample and hold module with a few fun tricks up its sleeve. You might already be familiar with the look of this module. Here's the this is what it will launch as, with the classic Instruō hourglass faceplate. So this module was actually shown off a couple of years ago, the same super booth that the Looper and the Arbor launched. But at that time, I think only about 30 or so were maybe made and sold as custom shop items. So it's a strange module. This is the original that I made, and it looks quite different. Basically, I completed Legend of Zelda Breath of the Wild and several of the expansions. So I think I completed the Champion's Ballad DLC and wanted to celebrate, so I made a module that looks like tech from Hyrule, because that's what you do, I guess. Yeah, so this panel doesn't exist outside of this and I think two others that I made as gifts for close friends, because that's Nintendo's design. So this is my design. It looks a bit more formal, but it's going to be shipping with a limited edition faceplate that comes in the box. That is designed by Dom, who you'll know from all the amazing manuals that were written by Colin Russell and laid out to make them look pretty by Dom. So this is his artwork. So yeah, you've got the choice of putting this panel on or keeping the classic. So these are going to be a limited batch. They're all analog. It's strange times because there's component shortages and all sorts going on, so lots of digital modules that I was intending to release soon are on hold, but I was able to source enough components to make these happen. I'll keep this video a bit more instructional and dig into how one might use a sample and hold. There will be other stuff out there. Ben Divgid is going to be doing a much more in-depth video than I, looking at a lot of different musical examples of this thing. And, yeah, hope you enjoy. Cheers! Let's play with some sample and holds. I'm going to be focusing on this Tágh here, and as you can see, we've got two outputs and two inputs. So the leftmost output here is a white noise source. The output here is the output of the sample and hold, and the signal input, it by default receives a normal from the internal white noise source. And then we have a clock input, but in addition there is a built-in clock that's controlled from this rate control and range of rate. So let's hear what it can do. I'm going to start simple, and we're just going to monitor a sine wave from this Nyoni, and I'll patch it through this low pass filter, just so we've got a bit more softness if the frequency jumps up. There we go, our starting source. And I'm just going to simply patch the sample and hold output into the oscillator's volt per octave. And here, very quickly, we can get that classic sci-fi computer sound. It's the sound of a computer computating, allegedly. So what exactly is happening? That's the main question. I'm going to patch the sample and hold via channel 4 on the scope here, and that way we can see the control signal as well as the audio signal reference. nothing patched to the input, we're getting the white noise source normal tier. So what a sample and hold does is on a clock signal, a rising edge signal, either from an external clock or from the internal clock, it takes a sample of where the input signal's voltage amplitude is and holds that. So sample and hold. So every time there's a clock pulse, it's picking essentially a random bipolar voltage from this white noise source. And then by varying the rate, I'm changing the speed at which it's going to be sampling these new voltages. As you can see, the rate is quite a wide range. It's an audio tapered pot, so it's got quite a nice feel over a usable range for just internal clocking, all the way down, and it's pretty slow. A button will also sum with that, so you can manually increment on the sample and hold. And all the way up, we're into audio rate territories, where it's not going to be hitting quite as high amplitude as the direct noise output, but it's pretty good. Even when sampling audio signals, you'll get up there into audio rate territories. The low rate range is considerably slower, so that's the fastest it will go, and it will go down to near enough stalling. So if you're wanting like really just slow ticking pulses or ticking random voltages, then you can do it in the box. Okay, how do we make this a bit more musical? Quick and easy way is to simply just quantize the random voltage. So what I'm going to do, I'm going to set my level all the way up so there's no attenuation over the input signal, and I can adjust the modulation depth from the harmonies attenuator. So as you can hear, I've got this set to a minor 7th scale pattern. Okay, so what the controls are, they're on the time. There's level control, so this attenuates the signal seen at the input before the sample and hold. So you're essentially scaling your input signal before it gets sampled. There's also this switch here, which engages a full wave rectifier. So it will take any negative portion of the input signal and reflect it to being positive. So the benefit of this is you can, at the hit of a switch, you can push your CV signal into unipolar positive domain. So depending on if certain quantizers might not look for it or might not take any negative voltages. It's also a quick way of restricting the range of a melodic pattern, where you might have the higher pitches when it's fully rectified, and you can immediately extend the range at the hit of a switch. Okay, let's improve this voice a bit so it's not just a constant running sine wave. I'll switch this out for the sawtooth wave. And I'll use the gate out here from the harmony, which is going to be firing a trigger every time the harmony quantizes to a new note, and I'll use that to trigger my envelope here. Then use that into the FM input of the filter. primary working parameters, I've got the rate of my sample and hold, which is the rate of new notes, and depth, which I could do at two different stages. I could do that at the tie, attenuating the output signal that's then being quantized, or I could attenuate it at the input of the harmony. It's quite good practice to follow the same rules that you would for gain staging an audio signal, where you want to retain the highest amplitude early on and attenuate at later stages where possible. Generally it won't matter with CV, but you know, the higher amplitude signal it's going to be easier for the harmony to latch to new notes and not land on any middle points where, you know, there might be system noise depending on the, you know, configuration of the system itself. So this is sitting pretty clean, regardless of where it's attenuated. Okay, so how do we get something that's more interesting than just completely random notes? This is where we start to play with different signals at the input of the sample and hold. Let's pull this one. So I'm going to pull this triangle LFO from the oct and run that into the input. So before that, I'll run it via channel 3 on the scope. That way we can clearly see what we're sampling. Max out the amplitude so that we're seeing the output following the same amplitude range as our input LFO, and reduce the depth here of the harmony. What you can see as I'm playing with the sample rate of the tie via the internal clock, we're getting different degrees of stepping following the input signal source, which is the triangle wave. So if I max this all the way out, then we're really not getting any difference than if I was patching this triangle LFO straight into the quantizer. So to demonstrate, I could even just directly short them out. So that's the raw triangle LFO into the harmony, and sampled at a higher sample rate. So this is where sample rate in this context, it's no different than, you know, the concept of sample rate in digital audio recording, where you know, it's just happening at considerably higher frequencies in general. So, you know, the lowest sample rate you'll be familiar with will probably be the common 44.1 kilohertz, which anyone familiar with digital audio, you might have heard the term Nyquist frequency. In a nutshell, it means that there's a maximum frequency that you can capture and record and then recreate by playing back and recording, and that is you need to be recording at least twice your maximum target frequency. So 44.1 kilohertz sample rate, that's going to, you know, the halfway point is going to be a little bit over the 20 kilohertz mark, which is, you know, that's the very peak of optimum human hearing. So I mean, if you can hear 20 kilohertz, then you're very fortunate. So what happens when you undersample a signal or approach that central Nyquist frequency? You get what are called alias tones, which is a big no-go when it comes to digital audio recording, because you're going to end up with weirder sounds that you don't necessarily want in your audio. But when we're working in control signals, then we can actually use that to our advantage. Before I move on, I'm going to just add another modulation signal in here. So this is just the lowest LFO of the oct, and that's going to be modulating the sawtooth wave shape of this nyoni. Just adds a bit more musical character to the voice, so it's not just a static tone every note. We get a bit more musicality. Okay, sample rate and undersampling. Okay, so this is in a position where we can clearly hear outline of our raw triangle modulator. And we can see the amount of stepping on the oscilloscope. Now we're not actually hearing every single note because the harmony is another stage of filtering out clock signal, so it's only going to be triggering the envelope on every new note. But we can still hear that overall pattern, but we're keeping it musical here. There will come a point when I reduce the sample rate enough that we stop hearing this overall outline of the triangle wave. And this is essentially an alias tone where there's a triangle wave there, we know as we've patched it and we can see it on the scope. But sonically, we're not hearing a melody coming from that follows that shape. Jump up to a slightly faster LFO here. So as you can hear, we're getting more into musical ostinato territories where there is some repeating characteristic, but overall the whole thing's just shifting and drifting. So this can be a very useful technique when you want some sort of varying pattern, but you don't necessarily want to dial in a full pre-programmed sequence. You want something that is following a general repeating melody. Simply patching up a sample and hold in this way, and you just need to tweak either the rate of your signal being sampled or the rate of your actual clock. Leaving the clock as a static, that's maybe the preferable approach, because then you've got a steady melody. And then adjusting your input signal to the sample and hold rate. Be a good setup to show the full wave rectifier a bit more clearly. I'll go back to a slower triangle shape, and I'll increase the rate of my clock. So now you can very clearly see the outline pattern of the triangle. If I engage the full wave rectifier, you can hear we've essentially doubled up the rate of our triangle signal because any negative portion is now being folded positive. So again, it works as a very quick way to change register overall of the resulting melody. Okay, I'm going to adapt this slightly, and instead of using the internal clock, I'm actually going to use the lower square wave voice from the CSL. So if I just patch in directly, this oscillator is now my clock. benefit of this setup is if I'm using a master clock from elsewhere in the system, it's already tied into what other rhythmic elements might be patched. So I could make use of logic gates, for example, to change up rhythms and use create subdivisions that are then clocking my sequence compared to my main drum voice or whatever. In this case, I could mult that square wave and then use that instead of the output of the harmony to control my envelope. So now even if there's a doubled up repeating note, we're going to get this envelope firing every single time. So I've got free running modulation over the sawtooth character of my main voice. Let's add another sample and hold into the mix. I'll use this tie down here, the funny looking one. I'll branch out my master clock. I'm now clocking the second sample and hold from the same master clock. And let's pull that out. Now have an additional running random CV that's tied to the same clock, and that's now patched to my CV input. Maybe a bit on the subtle side. What I'll do, I'll change from being the sawtooth wave to being the wave folder. And then change the CV to control the wavefold depth. Bringing up the slew level on the wavefold modulation. That's gone from very sharp jumps to slewing them a little bit. We're getting some hidden notes here, and that's when this so happens to sample something that's particularly negative, as this is pulling the wavefold depth down, and the Gnoni in particular, if it goes into the negative, it will actually mute the signal entirely. yeah, it's a very fun way to create naturally evolving sequences and melodic patterns. Yeah, sample and holds. Very useful modules. I hope you find this helpful.